Welcome to Maths and Science by IITian channel. As discussed in the previous lecture, that is 11th lecture on complex functions or complex analysis. In this lecture, we will be discussing about the complex functions instead of numbers. Numbers we have discussed almost for about 11 lectures. Now we will be discussing complex functions. Now, the question given here is to plot a function z, that is complex function. Z is such that z is equal to x plus y. That z is a complex number. Then we have to plot x cube plus 3z plus 5 by z. This is what is to be plotted. Now, we will go into the details. What is given? Function z. Z is a complex number because z is such that z is equal to x plus iy. What is the equation? Z cube plus 3z plus 5, z cube plus 3z plus 5 by z. This cannot be directly drawn on a plot of xy because xy plane itself is z. It is a function of the z. It's not z. Here, let us say it is a point P, xy, or rather we can say instead of P, we can say zxy, and regarding this we have discussed a lot. This is the modulus of z. This is the origin OO, because we should have a reference. Even refer to my previous lectures on vectors also to understand this. Now, z is equal to x plus iy. That is the condition given in the problem. Z is equal to x plus iy, and we have to plot function z, z cube plus 3z plus 5 by z. In the plane of x and y, we cannot plot it. If it is only a real number and something like x square plus y square plus z square, x square plus 3x plus 4 is equal to function x, we can plot it very well. Function x we can treat it as y-axis and x-axis as the variable. But in this case, the z itself is not represented by a single line like a real line or an imaginary line. It is represented in a plane of real and imaginary axis. Now, how to plot a function of a plane? That is the complicated one. It's not as simple as it is looking. A plane is a 2D. A function of a plane is more than 2D. It's not 2D. Directly plotting x and y coordinates for function of z is not possible. Then function of z has to be defined differently from z. Z is defined as x plus y. Can we say function of z is equal to some w that is equal to u plus iv, because function of z is also a complex number. Instead of xy plane, we can draw a UV plane This is imaginary, this is real, u is real, and we can put one, instead of z it will be function z. And it is origin. And this is z plane, because we are dealing in z, point z. Here it is not z plane, function z plane. Function z we said it as w. This is called as w plane. That means we cannot directly plot xy on xy plane for a function of z. You have to transform the coordinates from xy to function z and a w plane with the transformed coordinates as u and v to be created separately, and this transformed w plane is the result of this function z. In z plane, we can't plot function z. We have to transform. This process of transformation is the basis for complex functions and also complex calculus, which we will be starting from next class onwards, complex calculus. For example, if we have to draw z minus z naught, let us see. Let us plot what is z minus z naught. We have seen z minus I, z minus 1, z plus 1, z plus I, z minus z naught. When x is 0 and y is equal to 0, z minus z naught. And it is in the form of x plus y. And x is equal to 1 and y is equal to 2 also, we can make it as a z naught. No problem. Z naught means need not be 0. It is a reference point. How to draw z naught plot? So please understand this concept. Then the other concepts will be easy for you. As usual, point z is there here. Zxy. And there is one point z naught here. This is going to be the basis for your calculus. There will exist one delta. It is not to scale, please don't worry. One delta such that when z approaches z0, when z approaches z0, function z minus some L limit when z approaches z0, function z minus L is less than epsilon. When z minus z0 is less than delta. Z minus z0 is less than delta. This is x plane, xy plane. Then it will be transformed to UV plane such that transforming process I am explaining you. This is real, this is imaginary, this real U, and it will be transformed to like this. Somewhere here function z corresponding to z, and z minus z0 here. Z minus z0 is less than delta, this is the delta, and function z minus L is less than epsilon. Let us say there is some point L, function z minus L, that is epsilon. Then this is transformed to this UV. Once you understood this process, then we can solve the given problem. What is the given problem? Z is equal to x plus iy, that is given in the definition itself. Function z is equal to z cube plus 3z plus 5 divided by z. From the definitions of the limits, when z minus z0, z tends to z0, or z minus z0 is less than delta, then function z tends to L or function z minus L will be less than epsilon. Then the transformation takes place in the conditions of continuity. Under conditions of continuity. About these, I will explain you in the next class where I take up the calculus directly. Now I am only giving a feel of the calculus. Please feel the calculus, beginning of the calculus when you are dealing with the complex functions. Then the conditions of continuity, limits, everything I will discuss when I really start the complex calculus, maybe from the next class onwards. Please wait for that. Now, in function z, let me say w, that is equal to u plus iv. Then we have to find out what is u and what is v. Then we can understand the behavior of function z. Function z is equal to z cube plus 3z plus 5 by z. that is equal to z square plus 3 plus 5 by z. Now we know what is z. Z is equal to x plus iy. Then what is z square? X plus iy whole square. That is equal to x square minus y square plus I into 2xy. And we have to find out what is 1 by z. That is 1 by x plus y, iy. By multiplying numerator and denominator by x minus iy, you will get by x minus iy, you will get x minus iy divided by x square plus y square. This is nothing but conjugate of z. Please recollect the meaning of conjugate from my previous lectures. Modulus of z. That is equal to x minus iy by x square plus y square. This is very, very important. 1 by z is equal to conjugate of z by modulus of z whole square. This is whole square. This you please remember, and please also understand from whatever from x plus y I have derived. Now, function z is equal to z square plus 3 plus 5 by z square plus 3 plus 5 by z is equal to, what is z square? X square minus y square plus I into 2xy plus 3 plus 5 by z. What is divided by z? X minus iy by x square plus y square. 5 into x minus iy by x square plus y square. Now, when you separate real numbers and imaginary numbers in this, function z is equal to, in terms of x and y, x square minus y square plus 5x by x square plus y square. This is the real value. Plus I into, plus 3 is also there. That is also real number. Plus 3. These are the real values. Plus I into 2xy minus y by x square plus y square. Then here, what is the definition of function z? U plus iv. This is u. All real numbers are u. And this is v. That is equal to u plus iv. That is w. Function z is equal to w is equal to u plus iv. What is the value of u? U is equal to x square minus y square, minus y square plus 3 plus 5x by x square plus y square, and v is equal to 2xy minus, it is 5y. Here it is 5y. 2xy minus 5y divided by x square plus y square. Once you know the values of x and y, z can be drawn, and once you know the values of x and y, you can draw function z also. With these values, x and y are variables here. U and y are variables. U and it is v. So u and v. It is imaginary. It is real. There is a point function z, that is u and v. With u as x square minus y square plus 3 plus 5x by x square plus y square, v is equal to 2xy minus 5y by x square plus y square. If x is equal to 0, y is equal to 0. U and v are undefined. The reason 0 by 0 is undefined. You try for different values of x and y, get the values of u and v, and plot function z. So that the function z is plotted in this way, and it has got lot of meanings in physics and also in mathematics to understand whether a particular function of z is analytical or non-analytical, and another thing, whether it is actually obeys the Cauchy-Riemann equations laws. And when we dwell into the limits calculus, you will be surprised to understand that very big integrals with single variables and multivariables and real numbers, in complex plane they are simplified. They are simplified to such an extent that you can solve the definite integrals in minutes. Solve definite integrals with ease by using the residue theorem. What is left over? This is the meaning, and I have taken a function z, how it is to be done, I have shown you. Now we will be going for types limits first. We will define the limit in the next class. Next class, complex calculus, that is limits, derivatives of complex functions, and define different types of functions. Now next comes, after differentiation we will go for integration, then you will see the wonders of the complex number. Very big, unsolvable and traditional manner, the integrals, definite integrals, improper definite integrals, improper definite integrals can be solved by residual theorem. Residual theorem in complex integration. Please wait for that. You will definitely see the fruits of this complex numbers and complex differentiation and complex integration to be more useful in our competitive examinations, where a direct solution is not possible, where you have to go by the indirect methods and short methods. These are the methods which can be understood, especially in electricity and magnetism, where closed integrals are there. There you will be able to solve them very easily, and please be patient. Until now, up to 12 classes, I have made you to understand complex numbers, definitions, basics, addition, subtraction, multiplication. Now we are going into the topic of complex calculus. That is the one of the best calculus methods we will be using and solving very complicated calculus problems. It will be definitely very useful for you in the competitive examinations. For that only I started with complex analysis and complex algebra and complex calculus. Thank you for listening to me. I am from Maths and Science by IITian channel. Please subscribe to my channel. If value addition is there, please share my thoughts to many people so that they will also get benefited out of it. Next is complex calculus. Well, in the beginning, we'll go slowly, try to understand the meaning of limits. Then we'll expand to the residual theorem to find out the definite integrals. Please have patience. Please subscribe to my channel for regular updates. Maths and Science by IITian. In the beginning classes, I went slow so that you will get the grip on the basics. Now we will go